Okay, good afternoon everybody. I'm a bit of a disembodied voice for this session. If you see a small furry creature bob into shot, that is my cat Fagin. Alright, so if he wanders over. Right, so this lesson is going to be on specific latent heat. And the reason that I'm doing it this way is because you need to know how to draw and label some graphs and also carry out an equation. Alright, so the idea with specific latent heat is that every time you change state, so between a solid, a liquid and a gas, you require energy to do that. That's pretty obvious. All right, so when a substance is melting or boiling, you're still putting in energy. So you're increasing the internal energy of it. Okay, so the particles are going to be getting more excited. There's going to be more kinetic energy of those particles. And what that does is it breaks those intermolecular bonds. All right, those bonds that are holding those particles in place, they're going to be broken. All right, now then, you need to know the specific latent heat when things are heating up and also when things are cooling down. All right, so you'll have to excuse me in the... as awful as it is, look at that, lost 2 nails, shocking. All right, so a change of state requires energy. So we need to draw, okay, a graph. Okay, obviously you are going to draw a graph onto your notes. It's going to be nice and neat. It's going to be in pencils and it's going to be with a ruler, which is obviously much more important. Now then, what we're going to have here is we've got a solid turning into a liquid. Okay, then we have something happening there. Then we have a liquid turning into a gas. And then we have something happening here. Now, what you need to do is you need to be able to sketch this graph. You need to be able to label this graph. All right, so what we have along the bottom is we have time. And then we have temperature up the side. Also, always make sure that you include your units. Okay, there we are. So what we've got here is we have got a solid. Okay, and here we have it's melting. Here we have a liquid. Then we have, oh, put that extra thing on there that I missed. Then we have a, oh, then we have it boiling, sorry, evaporation. And then we have a gas. All right, so that's what's going on here. All right, so if we look across, all right, where we've got the melting, I've put MP there for melting point. This would be the temperature of our melting point. And here, if you go across, oh, make sure obviously it's straight. I'm trying to do this one hand. Here we have our boiling point. So it looks a little bit like this. Okay. Now, what you've got, the flat spots on this heating graph, is where the energy is being transferred by heating and it's not being used to change the temperature. All right, so the energy is being used at these 2 points. This is where the change of state is actually occurring, and any energy that's being put in at this point is being used to change the state from solid to liquid. So it's at this point here where that energy is being used to change the internal energy and is being used to break those intermolecular bonds. Okay, hopefully that makes sense for you. All right, now then, on the opposite way, when a substance is condensing or cooling, all right, we almost have kind of like the opposite thing going on. Oh, needs to be straight. Honestly, trying to draw these things with one hand. All right, ignore these dodgy little lines in the middle here. Okay, so again, but it's still the same. You've got temperature and we have got time. All right, and what we've got this time is we've got a gas to a liquid to a solid. Okay, and from the last session that we did, you should know that a gas turning into a liquid is condensation and a liquid turning into a solid is freezing or solidifying. All right, now again, when a substance is condensing or freezing, the bonds are forming between those particles, all right, and that releases energy. This means that the internal energy decreases, but the temperature doesn't go down until all the substance has turned to liquid or all the substance has turned to solid. So again, the flat spots are the graph showing the energy transfer. Now then, the reason that this lesson is called specific latent heat or latent heat is because the energy needed to change the state of a substance. So here, 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 and here, that is called the latent heat. Okay, now every substance has its own latent heat. Okay, every substance has its own melting point and its own boiling point. Okay, now the specific latent heat of a substance is the amount of energy needed to change 1 kilogram of it from one state to another without changing its temperature. So for cooling, specific latent heat is the energy released by a change in state. And it's different for different materials, like I just said, and for changing between different states. All right. Now then, the specific latent heat for a solid and a liquid. So solid to liquid. Okay. Obviously, I'm hoping you all know what that state change is. That is obviously melting. Okay. Okay, now obviously you've also got the other way around as well. So you've got melting is that way, and then obviously that way you've got, and then that way you've got freezing. Okay, but both of these, the state change between a solid to a liquid, they're both referred to as the specific latent heat of fusion. Okay, specific latent heat of fusion. And then when you are going from a liquid to a gas, so liquid to a gas, obviously liquid to a gas is evaporation or boiling. And then going the other way, you've got condensation or condensating. All right, and this is called the specific latent heat of vaporization. Okay, so we've gone from this graph. So you need to be able to explain this graph and what's going on, and the fact that you have got what the flat parts of the graph mean. And we've got the two definitions. Okay, here the specific latent heat of fusion is the energy required to change a state between a solid and a liquid, or a liquid and a solid, and the specific latent heat of vaporization is a liquid to a gas or a gas to a liquid. Now then, the last thing we need to do in this little topic, which obviously is a much longer video than we have done previously, is we need to be able to work out the energy that is required for the specific latent heat of something. So in this case, energy, okay, that is required is the mass of the substance times its specific latent heat. Now I'm being lazy and I'm writing it out like that. Now the units of energy is in joules. Sorry, energy is that. Well, actually, no, energy in the unit is joules. The letter that we use in the equation is E. Mass, that is in kilograms, and specific latent heat, we call it L, and that is in joules per kilogram. Okay, so we've got the units at the top, we've got the letters underneath. So if you want to know, so just for it's E equals ML. Okay. Now then, so for example, the specific latent heat of vaporization for water, okay, so water's specific latent heat equals 2,260 million joules per kilogram. Okay, how much energy is needed to completely boil 1.5 kilograms of water at 100 degrees C? Okay, now then, all you've got to do in this situation, okay, is asking for energy. So energy equals M times L. We've got our mass, which is here, and we've got our specific latent heat, which is here. So all we've got to do is plug in those two numbers. All right, so 1.5 times 2,260,000, and that gives us 339,000. Okay, joules. You always want a unit. Okay, so that is all that I'm going to be talking to you about today. I'm going to give you a few more examples of these. What I need you to have, though, in your books or in your notes is you need to have the definition of latent heat. You need to have the definition of the specific latent heat of fusion, the definition of the specific latent heat of vaporization. I've just realised I spelled vaporization wrong, by the way, ladies and gentlemen. I do apologise. There's no U in there. And then I need you to have these two graphs labelled, okay, fully. Make sure that you include the, because I've not done it here, make sure you've included your units, okay? That's all for this lesson, and check your Google Drive for the work that I need you to do. Hope that all makes sense. Speak to you soon. Bye.